Now, again, I think if you want to, yeah, if you have any questions to ask, just use the chat or feel free to shout things out, whatever you want to do. Um, so this is software engineering. Um, let's see. Uh, wonder what is this going on here? Wonder if this thing works. I guess not. Well, didn't go to Google. I'd like to browse this together. So hopefully you can all see this web viewer. Just going to take a look at what's going on here. What? Yeah, I don't think this is going to work. Oh, there we go. It actually worked. Cool. Okay, so for software engineering, we do have homework 5, which is alpha, due at the end of the week, which means we need to talk about beta this week. Sort of what I had blocked out to do is talk about beta and talk about MVVM, as well as talk about object pool. So today we'll talk about MVVM. I think some of that's going to bleed into Wednesday because I've got a nice MVVM example, all that I've coded all from scratch on my own. It's not from some GitHub or something, but it's on my other computer, and I don't know. I suppose. Well, we'll see how far we get. I might try to download Blackboard Collaborate for that computer and restart a session, or I'm not sure. We'll see when we get there. But that's either going to be Wednesday or today. But I tried getting it going on this machine, and there were some issues. So in any case, let's get back to this here. I don't know what's going on. Oh, here we go. Okay. So hopefully you can all see the presentation. This is from SunGard, which is a consulting company. And they were, this is sort of a resource that I'd used when I first started using MVVM a couple years ago. And I thought it was a good set of slides, so I figured, well, why not just credit them and use them? So this is from SunGard. Well, I don't know where there was a page that but anyway, you can contact them if you want more info or if you want to know where this came from. But what I plan to do was I'll just go through these and talk about them. I've got my own takes on some of this stuff, my own opinions, whatnot, and then show some code. So, so there's this thing called WPF, Windows Presentation Foundation, and it's basically a replacement to the old school MVC that used to be around, and or MFC rather, MFC, and MVC is Model View Controller, but MFC was Microsoft Foundation Classes, and so WPF is sort of an industry standard at this point. And we want to talk about, well, so exactly why is that? Why is it so prominent? What are some of the pros and cons of it? So in traditional WPF architecture, you've got your domain objects, which is your model. Then you've got your view. You've got your XAML, which is your UI layout. So you saw some of this in the MVC that we were doing last time. You've got your XAML layouts basically, and then you got your code behind. Now, basically, the code behind is this is the CS This is the dot CS. That's what the code behind is. So the code behind is literally your C# file or whatever other language you're using, usually C#, that's sitting behind the UI. So the UI sits there and it's got its definitions in XAML, which is a very XML-like structure that just defines the UI. That sits there in the view. That's all in the view. And the CS here, the code behind, is also in the view. Now that's an important part that I'm going to come back to when I present my own code, because quite often it's thought that the code behind here is bad. So this, I'm going to label this as bad. It depends on the company you're with, but code behind can be problematic because really, we'll get into this in greater detail. I'm probably getting ahead of myself, but really a view should be literally just that. It should be a view. It should have some UI information. That's about it. Code behind should be somewhere else in MVVM. And the question is, well, okay, where should that be? And so that's what we'll get into. So here's how that looks. This is some XAML, a stack panel with a city and a country list, and then some code behind that that is actually getting that information. Now you might say, okay, well, if we didn't have code behind for this, how would we actually do it? The answer is in bindings, and we'll talk about that more. But basically, you do some bindings on your XAML that go into your various view models that actually have the code then, and then it's outside of a view. The guy that wrote this gets into some pros and cons of this. That is the traditional model off the shelf. They intend you to do the code behind, but it gets very, as I said, problematic. You're doing everything in the view, essentially. You've got your model in your view. You don't have a controller. You don't have a view model. It's literally just the domain objects and the view. You get your business logic, your C#, all your stuff that you're doing, your logic processing, all mixed up inside the UI. It can tend to be a nightmare at various times. So the question is, what is MVVM? Well, the model shouldn't really know anything about the view. The view is just a UI element, like a window. So the question is, how do we fill the gap? How do we get between the model and the view? How does the clicking on the view impact the next view that's going to be shown and the next data that's going to be shown? And that's where really the something comes in. That's the controller. As I said, code behind, generally avoid this. I've been in interviews where we ask people what they think of code behind, and people that say that it's a good thing just aren't invited back. I mean, it's literally it can be a red flag, basically, put it that way. So generally speaking, again, it all depends on where you are, but generally speaking, that's something you want to avoid. It's the controller, or perhaps an MVP, the presenter, or maybe the VM, the view model. That's the something that we want to talk about. That control between the model and the view is something we want to talk about. So in MVVM, we have this idea of a UI state, and he's got his reference here too, so these slides also didn't come out of nowhere. He took them from a blog post. As is typical in computer science, we sort of rehash things and use each other and build ourselves up. So this is from the John Grossman blog post about MVVM, one of the originals, 2005 or so, where we're seeing that basically the view model has this thing called a data context, The data context is important because inside of the view, you're going to have data bindings. And the question is, how do those data bindings know where to go? Well, because of the data context, they know to go to the view model. So the XAML is going to set up a certain data context. That data context, therefore, knows that it should go to the view model for its code instead of putting it in the code behind, essentially, is what we're doing here. So this is all about, this comes back to Gang of Four Concepts, which is one of the books for the course. Which one of the things about Gang of Four design patterns is separation of concerns. So we know that, for example, if you're reading a list of countries from a database that you're displaying on a screen like they've presented in these slides, the model should have that list of countries. The view should position them on the screen, and the view model validates the input and shows any errors any errors that are inherent in that list. Similarly, let's say you're creating a shipment, you're making an e-commerce site or something like that. You're creating your shipment, your list of things to be shipped. The view model can control the situation. It can call down to the model to create that shipment data, to put in an array, to do whatever it is it's going to do with it. The view literally is just the appearance of the UI. So the view model knows how to push that down to the view, but it also knows how to create it inside of the shipment. So those are just a couple examples of separation of concerns. Important to MVM is the view is isolated from the model. So that's a biggie. The view model shouldn't manipulate controls directly. That's the view that's doing that. If we can do all of these things, we can therefore keep code behind to a minimum, which is the end goal in all of this. The way I'm presenting it, it's almost starting to sound like some kind of dogmatic thing, like a Windows versus Mac kind of argument, where it's like, they said not to use code behind, so I'm not using code behind because it's got a bad rap and I don't want it. Well, why is the question? And so we keep saying code behind is bad, code behind is bad. At the end of the day, you can trust me on it, or you can try to develop an app that's got 10,000, 20,000, maybe more lines. By the point you get to that, you'll start to see why code behind is troublesome. It gets very messy very fast because everything gets tied up in that C# file. You're dealing with UI things like button clicks in the same places you're dealing with calls to your database, and it gets very messy. So that's why they're saying we keep code behind to a minimum if we follow these traits, if we follow these things. All right, so looking at some code. This is a data binding. So this here, text box text equals binding city. This is XAML. So this would show up in the XAML, right? So that whole line is from the .xaml file. This is going to be a .xml file. Now, instead of having code behind now, that would be like .xaml. In the old days, you might have had .xaml and then .cs, and all your code behind would go in there for that particular XAML file. Instead, we're going to have a new class called main window view model, and this is going to be a .cs in your project. And because the data context was set to this, when you say binding city, it looks through this data context for this binding and it finds string city, and knows that it has a get method and a set method. And those gets and sets are used on the UI here. All right, so this is the crucible, I guess, of WPF, is the data binding concept. If data binding didn't exist, it would make our lives for MVVM very difficult. Now, we can have another thing that we call dependency properties. These are similar in a way to C# properties. You define them. So like boo, for example, grid row 2. This can be a dependency property. The dependency property basically comes with a bunch of functionality, like property type, change the callback, validation checking, and then you can implement each of those on your own. So this dependency property would be defined as a text blocks text in the XAML file as a dependency property, and then we could modify it in the view model. So here we have the dependency property, which would be in the view model. And this is binding that to the dependency property. So you can essentially, what I'm trying to say is you can essentially have, and we'll see this because I use some properties in my example that I'm going to show you, but you'll essentially see that properties that are defined in view models can be bound to. The reason you'd want to do that is because you will get all this extra baggage, validation checking and things like that, which you can use inside of your view model to make sure that the ranges are correct and all that kind of stuff. So now each control, and by control I mean UI. This is talking about UI. Control, usually when we say control, we're referring to the UI. So the control, which is in the UI, has a data context, and that can have a certain binding. Converters are for things like if you've got a string and you got to convert that to an enum or whatnot, or float to a certain smaller value float, or integer, something like that. So taking a look at some more of the code, this is he's got a shipment code snippet that he's showing you here, and I'm going to show you a Magic the Gathering card organizer. Similar kind of idea. It's basically a model view model. In his, he's got the model being the country, the subdivision, the shipment, and the main window view model has all that information. It's responsible for sharing it to the view, which is the main window. This is the view here. This is the view. So finally, we share that information down here with the main window. This is the bindings map. Model.country is country, country.subdivision name. That's going to show up in the XAML. Now, another concept that is very important, crucial, I would say, to WPF is the idea of commands. So this kind of gets beyond MVVM in a way, but I wanted to. The thing about it is that I want to be sure to cover enough WPF so that you can go out there and you can be dangerous. And that's really what this is all about. So I'm going to go over this last set, this second half of slides. I'm going to go over faster, perhaps, than I did the first, because this is more specific WPF stuff as opposed to design pattern stuff. So the WPF thing that you do if you want to click a button, for example, is you do it as a command. You do a public I command, say button command equals binding ship command. That goes to an I command that does the shipping. Commands can either be executed or not. That's what the can execute is for. There's also this idea of delegate commands, which we'll talk about a little bit later once we get to event-based scenarios, so I'm going to skip over that for the most part. We've got attached behaviors that can go on to dependency properties. So certain things can happen if, for example, you selected Hartford. Now, the nice thing about all of this is you can set up some pretty nice unit tests in C# in Visual Studio to test your model, to test your view model, to test your bindings. So, data bindings can be difficult to debug. That's a big problem. If a data binding isn't working, if you're not sure where it's binding to, it can be troublesome. Another big thing is performance issues. I've seen this. I'm on a primarily WPF application now myself, and I've seen this tenfold. There's a lot of code that goes between, clicking that button or sending that information down from the binding. And sometimes it ends up being a WPF specific error that's very hard to track down inside of windows.system. So you can have some weirdnesses there. So views, we use a command to do something. We also have this thing, as I said, called event-based, which is having the view listen to events on a view model. So if something changes in the view model, we can have like a on notify, for example, or on property changed, then do something in the view. And again, not going to focus on that strictly too much here because we haven't covered event-based patterns yet. But that said, here's an example from John Smithen for setting a data binding for focus. So we've got a focus mover, focus binding. So setting the focus of something. You can take a look at that and see all the various moving parts about setting focus. So this is a slightly different version of MVVM, which incorporates iView, which is basically a higher level class from view. And then the view model is going to know what kind of calls can be implemented and callable. And the shipment demo actually uses this. So, comparing this to other design patterns that have been popular throughout the years, mostly in Microsoft land, we see a few things. We see model view controller, which we talked about last time from 1979. Model view presenter, very similar to the model view controller. We have presentation logic only controlled in one aspect of it. Passive view, which is more of like an observer pattern, because you register yourself as a observer on a certain presenter. And then presentation model. So that's these last ones I wouldn't focus on too much. Just wanted to give some context. Another one that one thing that I'll talk about that I'm going to show you. This will be a good prep for next time because I'm going to have this working. The thing I'm going to show you is basically MVVM, which I've showed you now, plus C. So the idea that we're using in the company that I'm contracting for is we've got a model, view model, controller. So really how this works in MVVM plus C is your model obviously goes to your view. Your view goes to your view model. But your controller is sort of stuck in between these two. So we sort of impose the idea of a controller between the view model and the controller so that the view model can call controller. So this is a derivation of MVVM, really, and you'll see how that works. It turns out to work pretty well for situations where you might have multiple view models that can do different tasks. Each of those tasks can be split up by the controller type that it is. And as I said, we'll see that next time we meet. So, generally speaking, don't like these videos to go too much past 30 minutes, so we're almost at the 30-minute mark. Generally because I think attention spans start to wane after that point. But we will have another video where I'm going to go into MVVM plus C, and we're going to also talk about object pools. So just to remind you, beta will be a discussion we have next time as well. Which is going to be homework 6, I think it is. So we will start talking about that next time. As far as other homeworks, let me just check the board quick here. I think that we're set to go. Labs, we had a part 2 lab last week, which was adding that memory button on the MVC. We're going to have a lab this week. I don't have it ready yet, but it'll be posted sometime today, due on Friday, and we're going to do something with MVVM. So if you're looking for something extra to study up on that. I'll post the slides, and I'll post the video as well for those of you that could not be here. So any questions on MVVM so far? You'll have a chance on Wednesday as well to ask questions. And then just a reminder, Friday is class as normal. Actually, it sounds like we're going to have one of the candidates lecturing on Friday in our class, but I'm not sure what the topic is yet, so stay tuned on that. And as always, we appreciate your feedback on it. Okay. All right, I guess we're good. I've got OS coming up. Just to give you a heads up, that's at 10 o'clock. Which is coming up here. So we'll be doing that pretty soon, and for OS class. All right, talk soon.